So we have learned the first order rate equation. We've also done the graphical representation. We also learned the units for first order rate equation. And then gradually I did almost, I think, 20 to 25 numericals for the first order rate equation. Please do practice all the numericals. And after that, let us come back to one more topic called pseudo first order reactions or rate equations. So basically, what is the meaning of this word pseudo? Pseudo means false. Okay, right. This is not important for us. Remember, pseudo first order reactions, why do we call them as false? Because false means this one, because in such reactions, the most important concept or the most important word which you should mention is, in this particular thing, you have to speak in terms of solvent. Yes. Now, that solvent also should be present in excess solvent. So whenever you're writing your sort of first order reactions or examples that they ask you, try to use this keyword excess solvent, so the examiner knows that you know the concept clearly. So let us write the definition. So pseudo first order reactions are the reactions in which one of the reactant is a solvent, yes, which is present in excess and whose concentration does not change, and whose concentration does not or doesn't change. This is what your basic thing, right? Now, because here, that means what am I trying to explain? I have a reactant A, I have a reactant B. It's going to give me a product C plus D, but one of the reactant here is a solvent. Let it be ethanol or let it be water, and that solvent is in excess. Now, here what do we write? Rate of a reaction. If I write, I am going to write only one. That is, rate depends upon the concentration of one of the reactant only. Though both are participating, the rate depends on only concentration of one of the reactant. Why? Because this concentration is almost stable. It will not change, isn't it? It is present in excess quantity. It is not going to change. So that's the reason. Though both are participating in the RDS, that is rate determining step, we consider the rate only for one. That is why we call it as pseudo first order. Means both are participating, but concentration is picked up only for one. That's why it is pseudo first order. Two, but considered for one. Done. So let us see the example. Suppose if I pick up an example, I said solvent, right? It can be both polar and non-polar solvents. Now, if I'm picking up, instead of A, I'm going to take an example called acetic anhydride. Just say CH3CO, CH3. This is acetic anhydride. This is what we have done earlier chapters also. Now to this I am going to add a solvent, that is ethanol. C2H5OH. One more, C2H5OH. First, as soon as you see this reaction, now this is your solvent. This solvent is in excess. Correct? Now, first take out this water molecule. Take out this water molecule. Done. What are we left? We are going to link here, cleave the bond exactly here. Let's observe CH3COO, yeah, C2H5. Okay, I'm just cleaving this bond here. I'll tell you what. Now, how do we get CH3COO, C2H5? C2H5. This part is over. Now, what are we left with? CH3CO. C2H5. That means we have 2 moles. So 2 moles of ester formation. So for such reactions, the rate of the reaction depends on K into only the reactant. Only one reactant you're going to take. That is CH3CO taken twice. CH3CO taken twice. Okay, COO taken twice. Right? This is only one oxygen, right? COO. This O taken twice. So rate depends on only one concentration terms. That is why it is called pseudo first order reaction, though both are participating. Let us write one more example. Suppose here I have ethanol as a solvent. Now I am going to take water as a solvent. Suppose I am going to take sucrose. Sucrose is C12H22O11. Sucrose. Now I very well know hydrolysis, it undergoes hydrolysis. That hydrolysis also you require water. That water also should be in excess quantity. So it will break up into two. One is, as you have studied, glucose plus fructose. C6H12O6. This is your glucose molecule. This is your fructose, which we have already studied in glucose chapter. So for such reactions, how does the rate depend? Rate depends on only one concentration terms. R is equal to K into K C12H22O11. That's it. So this is how both are participating. Because of the excess amount of solvent, the rate depends on only one concentration terms. This is your pseudo first order reactions.